Okay, so this is my video for ICP5. I'm going to get over to the top here. I separated these all out into separate code snippets so it'd be easier to show, but I will run them all still. So for the first one, I'm going to run this line. I've already done the drive.mount line, so I'm going to run this to change the path to CSV to the diabetes. Okay, and then I'm going to run this. So this is just the standard standard code, the one that was provided for us, which, as we will see, has an accuracy of 66%. So in this one, I simply added a couple layers to here. I had the ReLU and the sigmoid layer, and then we'll run it again. And as you can see, once this is finished running, this now gives us 77.6%. I will now change this to the breast cancer CSV file, and really quickly I'll run through the things I had to do. I had to look up and research a little bit to figure out exactly how I was going to make this work. I learned that this was a thing I could import to help me. So I read in the data as normal, like I did before. Then I remove the column titles, which is like, sorry, these here. I remove these. I thought that would get removed in the header none, but it didn't work. And then I removed the ID and empty columns, which is just this column here, and then this ID column here. After I do that, I kind of like this one, I believe, moves the data and like recenters it or puts it back on the 0 axis. And then I set the X variable and Y variable for the ranges for my my training, which is, this is the every row and column but diagnosis. This is just the diagnosis column. And then simply do the normal one with these variables here. I had a lot of problems with the file type, so I found that I could convert them to floats or float 32s, and that worked. And then we run the code, and we find that we get an 85.9% accuracy. I'll run it really fast just to show. This time 88.9. So it's already pretty accurate. But then here I add normalization with the sklearn.preprocessing standard scaler. I make my standard scalar variable here, my scalar variable, and then I scale the X data, because that's like the body of our data. And I change the variables here as well, and then I'll run this. And then this ends up being 96.8% accurate, so that's a lot more accurate.